Hi, welcome to Tammy the Tutor. Today we are in CC2, lesson 1.2.1. Number 57. Joyce's dad packs her lunch and always packs a yogurt. Joyce knows that there are 5 yogurts in the fridge, 1 raspberry, 2 strawberry, 1 blueberry, and 1 vanilla. Her dad usually reaches into the refrigerator and randomly grabs a yogurt. So which flavor is the most likely that she'll have in her lunch today? Okay, so we have 1 raspberry, 2 strawberry, 1 blueberry, and 1 vanilla. So you can look and see that there's more strawberry than there are of the others. So she is definitely most likely going to get a strawberry if he's just randomly reaching in and grabbing something. B, what are her chances of finding a vanilla yogurt in her lunch bag? Okay, so if you're finding the probability, you want to create a fraction. And so you need to find the total amount of yogurts that there are. So that there are 5, and out of 5, there's only 1 vanilla. So the chances of her getting a vanilla yogurt are 1/5. Copy the number line below and place the following probabilities on it. Okay, I see fractions, percentages, and decimals. Some of you might be just fine being able to put all these different kind of mixed numbers on a number line. Some of you might feel a little bit more comfortable if you make everything a fraction or everything a decimal or everything a percentage. There's really no right or wrong way to do it. You just have to find out what feels best for you. I will maybe turn everything into a percentage. So we've got 1/4 in a fraction. Well, by now you probably know that's 25%, because I always think about quarters when the denominator is out of 4. So out of 4 quarters, I only have 1. 1 quarter is 25 cents, and out of 100, right? So it's 25%. This one's already in the percentage form, so I'm just going to write that down. We've got 8/10, so we know that's 80% in the fraction form, okay? Because I just looked at that decimal and it says 8/10. If I want to turn it into a percentage, you want to make your denominator 100 because all percentages are out of 100. Well, I can easily multiply this bottom times 10 to get 100, but what I do to the bottom, I have to be even and do it to the top. So that's 80 hundredths. Okay, I have 5 8s. There's no magic or easy way to figure that out. There's no nice way to multiply 8 times something to get 100. So this says 5 divided by 8. So 5's being divided by 8. I can't divide 8 into a 5, so I'm going to add a decimal 0. I'm going to go ahead and put my decimal on top before I forget. I've done that before. So 8 goes into 50 6 times. 6 times 8 is 48. Subtract 2, bring down another 0. 8 goes into 22 times. That's 16. Subtract, bring down another 0. And that goes in 5 evenly. Okay, so if we have that as our decimal, you can easily turn a decimal into a percentage by finding your decimal and making 2 hops to the right. 1, 2. So that's 62.5%. And then we have 1/100ths right here. So if it's 1 out of 100, we know that is just 1%. Okay, I'm going to erase this. Looking kind of messy. Okay, now we can put all of this on our number line. I've got a couple of 25%. So the first thing I'm going to do is divide it in half, and that represents 50. So half of that would be 25. Okay, so here's our 25%. So both A and B represent that. So I'm just going to write A and B on top of that line. C is 80%. Well, if this one is 75%, let's just go a little bit further, and then that should be 80%. 62.5, well, if this is 50, let's just go a little further, and that should be around, maybe a little further, around 62 right here. And then 1% will be right after the 0. Wait a minute. Sorry, this one should be D. There we go. Okay, 59. Write theoretical or experimental to decide the probabilities for each of the following situations. Well, let's talk about the difference between theoretical and experimental. Theoretical is when you don't really know exactly what's going to happen, but you just theorize or you think it's going to happen. For instance, if I am going to walk into a store and I think there's a 70% chance that I will run into somebody I know. Well, that's just my theory. That's just what I'm thinking. And it might be really logical and it might even be true, but it's just my theory at the moment. I haven't done anything to really see what did happen or the statistics. So experimental, on the other hand, is, and it's in the name, experimental. If I perform an experiment, let's just say I've got a bag of marbles and I want to know what the probability is that I pick out a red one. Well, I've got all these different colors, and let's just say I pick out a marble randomly 10 different times and I record exactly what happens. And so at the end, I can look at the numbers that I've recorded and then I can actually give a probability according to what actually happened. That's experimental. So let's see if we can make that make sense with the situations they've given us in the book. A says the chance of getting tails when flipping a coin is 1/2. Well, I think we all know that that is true, but it's just because we know that there's only 2 sides of a coin and whatever you're flipping is 1 out of 2. It's not because I flipped a coin 10 times and I wrote down how many times I get tails, right? So that's just technically theoretical. B, I flipped a coin 8 times and got heads 6 times, so the probability is 6/8. Okay, that is a perfect example of experimental. She performed the experiment. She flipped the coin that many times. She wrote down everything that happened, and so she was able to give 6/8, which is exactly how many times she got heads. Okay, see, my mom packed my lunch 3 of the past 5 days, so the probability of my mom packing my lunch is 3 out of 5. Okay, again, that is experimental. She kept track the last 5 days exactly when her mom packed her lunch, and she did it 3 times out of the 5 days. That's experimental. The chance of winning the state lottery is 1 in 98 million. Okay, that's just theoretical. That's just what you're thinking. The chances actually might not even be that good. It's not like you entered the lottery every day for a year and then you wrote it down. It's just that is your opinion. That's what you're theorizing. Okay. E, based on math models, the chance of rain today is 60%. Okay, well, another way to figure out what's happening is to use math models. You know, scientists, they have their weather instruments. They probably recorded all of the data and they looked at the numbers, and then that's where they came up with the 60% chance. It wasn't like they just walked outside and said, you know, it's kind of been raining lately, or I just think. It's because they had math models, used scientific instruments, they recorded data, and that's like experimental. Okay, Lena got 3 hits in her last 7 times at bat, so her chance of getting a hit is 3 out of 7, or 3/7. Again, that's experimental. They watched how many times she batted, and then they recorded every time she got a hit and wrote down 3 out of 7, so that is experimental. Okay, I think that's pretty self-explanatory. There are situations once in a while that makes you think, ooh, I feel like that could be either way, but most of the time it's pretty obvious the difference. Okay, Mariana represented several percents as portions of 100 in the pictures below. Write the percent represented in each picture. Okay, so you can see that this array is divided into 100 equal parts, and a lot of them are shaded, so they just want us to give them the percentage. Well, it's easy to figure out that each row is 10, each column is 10, so really, if I just count 1, 2, 3, 4, 5, 6, 7, 8, I know 8 times 10 is 80, so 80%. And the reason why I know that is just 80% is just so you know, if out of 100, 80 are shaded, I know that's 80% because the whole definition of a percent means it's out of 100. Once you have the number out of 100, that is just the percent, okay? So out of 100 on this one, there's one row of 10 and 11, 12 and a half. Look at that, there's that. So that's 12.5%. And this one out of 100 has one row shaded, so that's 10. So that would be 10%. Now write the portion represented in each picture as a fraction at least 2 different ways. Oh, well, actually we've already written the fraction in one way, so let's see how else can we represent 80 hundredths. We can reduce it down to 8 tenths. We could reduce it down to 4/5 if we really wanted to. So another way to write this as a fraction is 12 and a half, right? Could have done 12 and 5 tenths. Okay, you can reduce that to 1/10. Okay. Find the mean and median for the lengths of the jumping frogs' bodies shown below, and the lengths are in centimeters. Okay. So the first thing we have to do is put our data in order from least to greatest, and then we're just going to find the number that is perfectly in the middle. That is what the median means. It's the one in the middle. So let me just organize my data. Looks like we've got 7.6 twice. We have 9.2. We've got 12.5. 13.9, 14.1, 15.6, 17.5, 20.3, and 21.7. Okay, good. So count up how many numbers you have total. That's important. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so to go in the middle, it's going to be 1, 2, 3, 4, 5. It's going to actually be between two numbers. So we just have to figure out what number lies perfectly in the middle of 13.9 and 14.1. This one happens to be an easy one. You know that if you go one hop up from 13.9, you're at 14. And then also if you're at 14.1 and make one hop backwards, you're at 14. So it's easy to know that 14 lives right in the middle of those two numbers. So 14 would be your median. If it wasn't a number that was easy to do mental math to figure that out quickly, you could always take the average of these two numbers to figure out what's in the middle. And what that means is taking an average of anything means to add them up and divide it by the number of numbers. Well, there's 13.9, 14.1, add them up. Okay, so we've got 28, and we're going to divide it by 2 because there were only two numbers that we added, and half of 28 is 14. I'll just do divided by 2 equals 14, okay? So now we have to find the mean. Again, another word for mean is average. We just played around with finding an average. It's no different. We're going to find the average, though, of all the numbers. So we're going to add up all the numbers and divide it by 10 because there are 10 numbers there. Well, I already did the work before I started this video. I added it up on my calculator and it added up to 140. So when I divide that by 10, because there are 10 numbers, the answer is 14. Now don't Don't think that every time you do this, your mean and your median is going to end up being the same number. I've seen it happen sometimes, but more often it's not the case. So just be careful and don't always assume that if you find the median, that's also the mean. Okay, last one. Craig is practicing his baseball pitching. He kept track of the speed of each of his throws yesterday and made the histogram at the right. Can you tell the speed of Craig's fastest pitch? Okay, let's look at this chart. The speed of the pitches are along the x-axis down here. And so obviously the fastest pitch is going to be right in here. Here's the problem though. We know his fastest pitch was between 70 and 75, but there's no way for us to know exactly which numbers that was. Let's see, that happened 2 different times, as you can see here. He could have gotten a 70 2 times. He could have gotten a 71 the first time and a 74 the second time. There's no way for us to know exactly because they've just given us a whole range. So the answer is no. B, between what speeds does Craig usually pitch? Okay, so here's the frequency is being shown here along the y-axis vertically. And so the one that goes the highest, obviously, would be the pitches that he has done the most. And that is between 50 and 55 miles per hour. And honestly, technically this bar represents between 50 and 54. But I've seen so many people just call it 50 to 55. Also, I've seen other people interpret this as, well, if you're looking at the entire graph, these 3 are the ones that he got the most because they're all quite a bit higher than the 3 smallest ones. So they've said, oh, between 50 and 65. And I'm like, okay, I can accept that. Either is correct. C, based on this data, what is the probability that Craig will pitch the ball between 70 and 75 miles per hour? Well, if we want to find the probability of that, we need to know exactly how many times he has pitched. Well, this frequency literally means how often something happens. We just need to count up all of these pitches, and then we'll figure out how many of those was between 70 and 75. So this bar tells us that only represents 1 pitch. This one represents 5 pitches. This was 3, 4, 1, and this one's 2. So if we add these up, 5, 10, 14, 6. Okay, so there's 16 total pitches. And between 70 and 75, that only happened twice. So we can reduce that down to 1/8. So that's the probability of him pitching between 70 and 75 miles an hour. Okay, I think that's it, you guys. Yeah, it is. Good job, and I'll see you next time.